Okay, we're looking deeper into the rock cycle and we're going to model what happens with rocks with starburst candy. And it's a very rough estimate, but it'll give you a visual for how changes happen with rocks and how heat and pressure can really make a difference in how rocks are shaped and formed. Okay, I've taken 4 different colors of starburst candies and cut them into small pieces to represent sediment. So each color represents a different type of sediment. Sediment can be sand that has been blown or washed into an area by wind or water. Another could be at the bottom of the ocean as marine animals die, the calcium in their exoskeletons um, layer upon layer and make a certain substance that actually ends up turning into limestone. Another color could be mud and different types of dirt. So this is our sediment that kind of starts out separately.
You can see some of the layers that might be repeating in a sedimentary rock. Maybe the yellow repeating the orange or the pink, because each color represents a different type of sediment that was laid down through wind, blowing dust or sand, and then continuing to lay down different repeating colors. The layer on the bottom is always older than the layer on top. It's called the law of superposition. It means the top is always going to be the most recent because new things fall onto the top. So this is our sedimentary rock. Each color kind of laid down in layers. Add a little bit more heat. So a metamorphic rock would be, it might still have the layers, but it's been pulled deeper into the earth where there's more heat and pressure. And so could be something like this, where there's some bends in the waves and the lines and the patterns. So wavy kind of lines because of the heat and pressure. So it's not totally melted rock. It's partially heated and lots of pressure. And very small crystals, if there's any. Then what happens is our igneous rocks, and those rocks are really melted down to a liquid, and then they cool under different conditions, which makes them many, many, many different kinds of igneous rocks. So I'll show you that next. Okay, I just pulled this out of the microwave, so I just put it in for about 30 seconds. A lot of times igneous rock might be mostly one color because the rocks have melted and been mixed together so that it's hard to tell one mineral from another again until it cools.
Okay, this is an overview of the rock cycle in a lot of detail. Some of you are not quite ready for this much detail, and that's okay. Just kind of take the general overview, and that's enough. But for those of you that are ready for a little bit more, I thought this is interesting because it shows where these the types of rocks take place. So let's start over here with the sediment. Okay, so weathering and erosion of volcanoes, land, mountains, any kind of rock, that weathering moves the sediment, deposits the sediment, and lithification just means turning into rock. When we talk about rocks like half dome, we call them a monolith, meaning one rock. It's one massive chunk of granite altogether. So lith, that root word here, means making into rock. So the sediment sits here, other things lay on top of it, the sun bakes down on it, and the little pieces of sand and mud bond together and become a rock. Now, The arrows show that this sedimentary rock can either be pulled in through tectonic plate movement and then be uplifted and exposed again to weathering, or it can be pulled down deeper into the earth depending on the two plates and how they're interacting together. Sometimes it's hard for our brains to wrap around how all this can happen because it happens often in places where we don't see, and it's very sudden. When the earthquakes happen, we're not really focused on what's happening to rocks, we're focused on what's happening to us. So here the sedimentary rock is pulled down, and you notice that it's deeper in the crust for a lot. This is miles and miles of sediment that is all being pressured, pressed down on top of itself. So that heat and pressure here caused change. And that change then can either be pulled up for uplift and exposuring, and those metamorphic rocks can go through weathering, be moved down a stream from fast-moving water, deposited, turned into rock as sediment again. Or it can get pulled deeper down and it can be melted and turned into magma. And here it becomes kind of all one rock again. All of the different minerals all combined together and really look pretty much the same. And then, depending on the dynamics and the location, either the magma will crystallize and turn into igneous rocks here, intrusive meaning they crystallize under the surface like granite, or they can be pulled up and they can come through this magma chamber here, and then when they cool in the air, they become extrusive rocks, and that would be obsidian and pumice, or basalt is another form of extrusive rocks. They cool outside of the crust in the air when it touches snow, water, or air. That's how the cooling happens. And then igneous rocks will be exposed to weathering, like all rocks are, and small pieces will be broken off and washed away as pebbles or as sand, and we go through this process again. So at any point in time, any igneous rock, metamorphic rock, or sedimentary rock can be uplifted and be exposed and just continue this loop right here. It just has to do with where they are, but all rocks are going through this cycle all the time.